The function is increasing and decreasing where we have positive and negative slopes. And remember, to determine that, our derivative is the slope. So we're going to plug in values on either side of our asymptote. So I've chosen +1 and +2, because those are fairly easy numbers to plug in. We're going to determine the first derivative using the quotient rule. Remember, quotient rule says the numerator is u and the denominator is v. The first derivative generally is u prime, derivative of u, times v minus u times the derivative of v, so v prime, all over v squared. So subbing in, we have derivative of u, derivative of 1, some number, is 0. Times v, we have 4x minus 5. Minus u, it's just 1, don't really need to write that. Times v prime, the derivative of v is just 4. Okay, all over v squared. 4x minus 5 squared. Simplifying this, we get 0 and -4 over our binomial squared. Now all that's left is to take our x values on either side of our vertical asymptote and plug this into the first derivative. Notice we're not using any x values of turning points. We're only using the x value of the vertical asymptote. Why is that? Well, we just don't have any turning points in this function. If you just imagine the function something like this, we can see that there are no turning points. There's just a vertical asymptote. You could ask, is it possible to have a vertical asymptote and a turning point? The answer would be yes. If we had some other function that had more than one vertical asymptote, there must always be a turning point between asymptotes. Something like this. Between the vertical asymptotes, we would have our other regions here and here. The x value of the turning point is always the midpoint between the two vertical asymptotes. So you can see sometimes we do have more than one point. Let's get back to what we were doing. So we're plugging the +1 and +2 into the first derivative. So f prime of 1 equals -4. You guys all know how to plug numbers in. F prime of 2 equals -4 over 9. I only care about the sign. The sign is negative in both cases. That's this. We have a decreasing function in all areas.